Welcome to this new how-to. In this how-to, I'm going to show you how you can use the navigation systems in the Fokker VIIb aircraft. In this case, the retrofit, right? So keep that in mind. The retrofit has two navigation systems. You can either use the NDBs or you can use the VORs. Now, how to figure out where those VORs and NDBs are? By default, if you go to the world map in Flight Simulator, they're hidden. But if you want to show them, you need to go to the filters and make sure that you switch on the nav aids option. That will show both the NDBs and the VORs. How can you recognize them? That's really easy. These ones, right, all the, I would say the small center with a lot of small dots around it, those are the NDBs. NDBs only have a frequency. So this is a frequency which you need to tune into if you want to use this NDB for navigation purposes. Then we've got the VORs, and the VORs are coming in two types. We've got the localizer DME, which are in most cases at the start or the end of the runways. They also have a frequency. And you've got the VOR DMEs. So DME stands for distance measure equipment. So it allows you to measure the distance, how far is it to a specific navigation point. In some parts of the world, the VOR part is currently being dropped, right? Because most aircrafts are using GPS. And then you can only use them for DME purposes. So you can't use them to, say, fly into a certain direction. In this case, you can see that it has both the VOR and DME capabilities. And this is the frequency which is assigned to it. Here we've got another one, right? If we click it, then we will find the information. So all kind of cool things which you can all find on the world map of Flight Simulator. So what we're gonna do is we're gonna go airborne. Let's say that we're gonna fly from Marseille. At least we're gonna start there. And then we're gonna fly to this beacon. That's the MRM, right? So we need to make a note of that frequency. And the reason why I'm doing it airborne is because the aircraft which we're currently using is very sensitive for crashing, and that's also what you read on the internet. It's really hard to fly with. So let's press fly and let's depart from, I would say, flying above the city of Marseille. So we're gonna fly to MRM, which is the beacon with the frequency 108.800. So that's the frequency which we need to configure into our navigation systems. And the navigation systems are here, right? So I'm gonna press fly now. Gonna make sure that we're not crashing. So we need to adjust the yaw damper a bit. Which is always crazy sensitive, as most of you know. And here it happens again, right? It simply is the sensitivity of the damage model is simply too sensitive, I would say. So let's try it again. So we're airborne. I will leave my stick pulled back a bit. So the thing we need to change is the frequency of the radio. So as mentioned already, it has two navigation systems. One is on the top, which has both the communication and the navigation radio, and one is at the bottom, which is used for the NDB part. Currently there's an issue with the NDB part because you can't change the second digit. As you see, normally you can press this button and then you can change it, but for some reason it doesn't work. So you need to report an issue with Asobo about it. The second one, or the first one, we can still use it, right? You can see a small knob here, which we can change. So we're going to change it to 800. And then we're going to use the large knob, which is on, I would say, closest to the dashboard, to change it. You can see that if you're moving it too far, it will reset the digits after the comma. So be aware of that. So we're going to change it to 108. Oh, it was 800. Sorry, I thought 300. And now to make sure that we're using this one as the active, say, navigation direction, we need to swap the signal. So currently this one is the active one and this one is the standby one. And what you will see is that this instrument will change. So I'm gonna hide this one and then I'm gonna press this button. And you saw what happened, right? In this case, it moved the this green line completely to the left. So if we're looking closer at this instrument, we can see a few things. First of all, we can see the arrow here, which means that we're flying towards the beacon. If you want to fly away from the beacon, then you need to make sure that this one is shown here. But how can we figure out what's the frequency or the direction which we need to fly to, right? That's where the course button comes into place, because the course button can be turned, and the course button can be turned either left or right, and you need to figure out what's the right direction, but in most cases you can figure out what it's approximately you need to turn it, because now if we would continue to turn, we would fly away from the beacon, and that's not what we want. So we're gonna turn back to the left and then continue turning. And you can see it now moves the needle, right? So the needle is now moved exactly in the center. So what you now need to do is you need to move your airport or your aircraft into that direction, right? So I'm gonna change it. Gonna change this button again. So that would mean that we need to fly into the west direction. And you can use the compass, which is shown here, to figure out which direction you currently are flying to. So we're gonna move it. Gonna slowly turn because we don't want to break the aircraft again. And if we're close to that 300 mark, which we almost are, we're gonna simply center the aircraft and then fly into that direction. Because this is the direction, and if we would follow this direction, we will end up at the navigation beacon. To show you that we're flying to it, we're gonna use the Navigraph plugin, which is again not for free, but so keep that in mind. And there you will see this beacon, right? This is the MRM, this is the one we just tuned into. The closer you will come to the beacon, the more this needle starts to deviate. Don't be, I would say, surprised that it will continue to deviate too much, because it will continue to deviate more and more. So the closer you are to the navigation beacon, the more it will deviate. Don't try to auto-correct the course, because you can't correct it. It will change the course eventually, or change the needle, sorry. Eventually the arrow here, it will point to the other direction. So we're gonna change this one again, so we know that where we can fly to, right? I'm also using this map, of course, a bit, but you can, let's say, you don't really need it, but it's just a handy tool. So if we pay attention to this nice system, you will see that soon, I would say, it will start to move again, right? And I'm not gonna adjust my course, I'm just gonna fly towards it. And what you will see is that this arrow will soon start to move to this direction, because we're flying away from the beacon. So be aware of that. Sometimes takes some time, right? Because we're now, I'd say, not flying, say, straight over the beacon, but we're just a few miles from the beacon, or a few meters probably, if I look at the map. You just saw it, right? Now we're flying away from the beacon. And that's what we call outbound. So you can either fly inbound to the beacon or outbound from the beacon. In some cases, outbound is also being used, right? If there's a lot, or if there's not a lot of beacons, I would say, in the, say, near you, then you can still use the outbound beacon to validate that you're flying the correct course. So now we're flying and we use the VOR system. Again, I'm really sorry to say you that I can't use the NDB one, and that's, I would say, really a pity that we can't use it, but let's have a look around. And you can see another one here, 117.30. So again, I'm gonna change the number here. First gonna change to 117. It was 30, right? 30. And press the button again. you can see that it moved direction again, right? So to figure out which direction we need to fly to, we need to move the needle again. And you can see that we need to fly a course of approximately, well, here's 240, 250, 260 or something. So we're gonna change the direction again. We're gonna move the aircraft so we can fly towards the beacon. So we're gonna turn, and you will see that it will come to the center more closely if you want. But I'm very careful with moving this aircraft because it's so sensitive. Continue turning. And now if we would, now we turned a lot, so we're gonna zoom into the system again. Change the button again, and in this case, right, we know the direction, so it's a little bit 240, right? So if we would fly this direction, the same, you can use the compass to validate, then you're flying the, say, the correct course. In some cases, when you have an autopilot, right, you can use the heading button to just make sure that you're setting it on the top. That's to make sure that you're, I'd say, marking the position where you want to fly to. Makes it a little bit easier, right, to see deviations. If this orange button moves, I would say, into the incorrect position, you're seeing it much earlier than this arrow, which is moving into the incorrect position. So for aircrafts with an autopilot, those can, I would say, use both the systems, so that's cool. So is it necessary sometimes to make adjustments to this course button? Yes, sometimes it's needed, right? As explained already, when you're coming very close to the beacon, then you are screwed, because then it will start to move. Now we're also screwed because the aircraft crashes again. So in this video we looked at the different navigation options which you can use. Unfortunately we couldn't look at the D and the B because there's a bug in that frequency button which we can't change. Hopefully they will fix it soonish. I hope you liked this video. If you liked it, then consider to use the like button. If you got questions or comments, then feel free to post them in the comment box below. And if you want to stay up to date about new videos I'm posting, then make sure that you're subscribing to my channel. Thanks for watching and see you next time.